The number of balls in a triangular pile is greater by 150 than half the number of balls in a square pile, the number of layers in each being the same. Find the number of balls in the lowest layer of the triangular pile. Okay, so let the number of layers be n. So what we are talking about is that we have a triangular pile of the lowest equilateral triangle being side of n balls. Okay, you have equilateral pyramid and you have square pyramid. Okay, so we are saying that we have n layers, so the lowest side has equilateral triangle side of n balls in both the case, right? So how many balls will be there in the lowest side? We have already seen that it will be simply n times n plus 1 by 2, and in case of square it will be n square. What will be the total number of pyramids in the what will be the total number of balls in the complete pyramid? It will be given by n times n plus 1 times n plus 2 divided by 6, right? And in this case it will be given by n times n plus 1 times 2n plus 1 divided by 6, right? Now the question says that the number of shots in the triangular pile is greater by 150 than half the number of shots in the square pile. So what will be the half of this? Half of this will be simply multiplied by half. Now it is given that this minus this is equal to 150, and we have to simply solve this equation. So we can take out n times n plus 1 by 12 as a common factor out, right? So you will be left here with 2 times n plus 2, so that is equal to 2n plus 4 minus you have 2n plus 1, so that is minus 2n minus 1. This is equal to 150, and this 2n minus 2n cancels. This is 4 minus 1 is 3 times 4, and therefore you get n, you have n square plus n. 4 times 150 is 600, so minus 600 is equal to 0, and you have to simply solve this quadratic equation. Now 600 can be written as 25 times 24, so this is n square plus 25n minus 24n minus 600 is equal to 0. You can factorize this as n minus 24 times n plus 25 is equal to 0, so n is equal to 24 balls. N is equal to minus 25 is negative result, so it has no meaning, so we will consider n is equal to 24 balls. So find the number of shots in the lowest layer of the ball of the triangular pile, right? So this will be given by this formula. So now n we already know is 24, so this is simply 24 times 25 divided by 2 is equal to 300 balls, and we are done. Find the number of balls in an incomplete square pile of 16 courses when the number of shots in the upper course is 1005 less than in the lowest course. Okay, so now we have an incomplete square pile. So our square pile looks like this. You have a top layer which is a square, and then you have a bottom layer which is also a square. Okay, so this is what our square pyramid looks like. It's an incomplete pyramid. Now we know that this number of courses is actually equal to 16, right? So suppose the number of balls, let's say let the number of balls in square inside of top layer is equal to n. So I am saying that number of balls in this is equal to n. So how many balls will be there in the bottommost layer? It will be simply n plus 15, and that will make 16 layers, right? So the balls in bottommost layer is equal to n plus 15, right? Now if we consider the total number of balls in the lowest that is in the lowest layer, it will be simply n plus 15 square. Okay, number of balls in lowest layer, that is simply equal to n plus 15 square, because this is a square, right? Now number of balls in top layer is similarly n square. Now we have been given this difference, so we know that n plus 15 square minus n square is equal to 1005, and you simply solve this problem. This will give you n square minus n square will cancel. 2 times 15 is 30n plus 225 is equal to 1005. So 30n is equal to 780, and n is equal to 26, right? So find the number of shots in an incomplete square pile. So now we have to find how many balls are there. We know that we have the number of balls in the topmost layer in each side is 26. So, but we have to find total number of balls in this square pile. So we know that the bottommost square pile, if we consider this complete pyramid, we know that we are talking about the complete pyramid of 26 plus 15. 26 plus 15 becomes 41. So we are talking about 41, a complete pyramid of 41 balls. So that is 41 times 42 times 2 into 41 is 42. 2 into 41 is 82, plus 1 is 83, divided by 6, right? So this is, and how many balls we have to subtract in the top layer is 26. So we have to consider a complete pyramid of 25 balls. So if I subtract complete pyramid of 25 balls, it will be 25 times 26 times 2 times 25 plus 1 is 51, divided by 6, and if we calculate this, we will get the total number of balls in this incomplete square pile, and this answer comes to 18,296 balls. 18,296 balls. Show that the number of balls in a square pile is 1/4 the number of balls in a triangular pile of double the number of courses. Again, this is a very simple problem. So let us first consider the square pile of side having n balls in each side. So that is given by sigma n square. So square pile will have n times n plus 1 times 2n plus 1 into 1 by 6 balls. Okay, now they are saying that you consider a triangular pile of double the number of courses, right? So now the triangular pile has 2n balls in each side in the lowest layer. Okay, so what will be the total number of balls? That will be simply 2n times 2n plus 1 times 2n plus 2 times 1 by 6, right? I am simply using the formula n times n plus 1 times n plus 2, but because the number of balls in the lowest most layer is 2n, so it will become 2n, 2n plus 1 and 2n plus 2. And if you simplify this, you have 1 by 6 times 2n n plus 1, and I can take 2 common out from here also, so this will become times 2 times we have made a little mistake here. It is 2n times 2n plus 1, right? This is 2n plus 1, 2n plus 1, take 2 common out and you get n plus 1. So this 2 and this 2 becomes 4. So this is 4 times 1 by 6 times n plus 1 times 2n plus 1, and we are done. We can see that the number of balls in a triangular pile is 4 times the number of balls in a square pile having n balls in each side. Okay, and this is what we had to prove. The number of balls in a triangular pyramid having 2n courses is 4 times the number of balls in a square pile having n courses. And we will stop this video now, and we will do the next 3 problems in the next video.